So now that we know what the different equations look like, we're going to start classifying some. So I have f of x equals 695 times 1.733 raised to the x power. So the fact that this exponent contains your variable, if you have a variable in your exponent, that means you're dealing with an exponential function. So means exponential. Okay, a variable in your exponent means it's an exponential function. So now we know that one. All right, so I want to know now, I have f of x equals 5 raised to the 2.1x. Okay, so first of all, is it exponential? Yes, it is an exponential function because your variable is contained in the exponent. Okay, so now I want to know what is happening. Does the graph increase or decrease? So based on what we know and what we did in the intro, your base is an improper fraction. So if your base is improper, then your graph will increase. Okay, why is it improper? Because I can write anything over 1. Okay, so that would make an improper fraction. So if your base is improper, then your graph will increase or grow as you read it from left to right. Okay, so if I have, if I want to try and plot it, okay, I know that every exponential function will travel through the point 0, 1. Every exponential function, unless I move it, will travel through the point 0, 1. I also know that every exponential function will travel through the point, unless I move it, 1 comma base. Well, this one is a little bit different because if I shove in a 1, I get 5 raised to the 2.1. Okay, so if I shove in a 1, then 2.1 times 1 is 2.1. So I would get 5 to the 2.1 power. Now on your calculator, you've got 5 raised to the 2.1 power. So I'm going to do 5 and then raised to the, sorry, my kids have my calculators. All right, so 5 raised to the 2.1 power, and that gives me 29.4. Okay, so you've got 29.4, and that should make sense because 5 to the first is 5. 5 to the second is 25. 5 to the third is 125. So you're just a little bit over 5 squared. So you're a little bit over 25. So now you know a second point. Okay, so let's try some more. We have described the graph of the function. So I have e raised to the negative 1.8x. Okay, so I'm going to approach this a couple different ways, but we're going to talk about e first. E is a number. Okay, just like pi is approximated, which is curly. All right, 3.14, blah, 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 blah. It goes on forever and ever and ever, all eternity, never stops, never repeats. Pi's job is to play with circles. E's job is to play with money. E's job is to play with money. It's not a variable, it's a number. So it's basically 2.718384, da 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 da, okay? So it goes on and on and on for all eternity. Your calculator has an E button. Now, a negative exponent, we've learned this because I want to know about the graph of the function. If I have a negative exponent, that tells me whatever he's attached to goes to the opposite part of the fraction. So this E actually belongs in my denominator. So now I've got 1 over e to the positive 1.8x, which I could rewrite as 1 over e to the 1.8x. Okay, because 1 to any power is still 1, so it doesn't matter. So now I want to know about my graph. My fraction is a proper fraction because it's 1 over 27183, whatever. Okay, so it is proper, which means this thing will decrease as you read it from left to right. So this one up here would have grown like this. Okay, this one is going to decrease like this as you read it from left to right. So he will decrease, or he will not grow, but decay. Okay, so we've got growth and we've got decay. This one will decay. Now, I need 2 more points. So I know that the point 0, 1 goes through, will travel. Every exponential graph will travel through the point 0, 1 unless, okay, unless I move it. Well, again, I've got a little weird thing going on up here. So when I shove in the point 1, or when I shove in an x value of 1, what do I get for an answer? So again, you have an E button on your calculator. And so I am going to take my calculator and do 1 over, and then I'll have E to the 1.8, because 1.8 times 1 is 1.8. So E to the 1.8 power is going to give you 0.16529. So 0.16529, which actually that rounds up to 1653. Okay, but that point is on your graph. So again, if you plot this thing, the 0.01 is on there, and then 1 comma, you notice that it doesn't go up to 1, so it's going to decay. Okay, so let's try some more. We have graph the function on paper. Well, there you go. All right, so we don't have paper because we're working online. So I have f of x equals 5 raised to the x over 9, which is also 5 raised to the 1/9 x. Okay, so a couple of things. I want to know, first of all, is it increasing or decreasing? Okay, my base is improper, so it is increasing or growing. Okay, second, I know that the point 0, 1 is on every exponential function, unless, okay, I move it or something, which means I can identify a second point, shove in a 1, and now I've got 1/9 times 1 is 1/9. So on my calculator, I'm going to do 5 raised to the 1/9 power. So on my calculator, I've got 5 raised to the 1/9 power is going to be 1.19 or 1.2. Okay, so 1.2. So I've got 2 points. I know it's increasing. So here's 0, 1, and here's 1.12. So it's going to be kind of sort of almost flat. Okay, so you're looking for that general shape, and you're looking for it to be somewhat flat-ish. Okay, and the graphs that you're choosing from, as soon as you know this basic stuff, it'll be pretty obvious which one it is. You just need to know the basics. All right, so let's try another one. I've got y equals 1/2 raised to the x power, and I want to choose my graph. Okay, so your base is proper, which means you know he's decreasing. Okay, I also know that the point 0, 1 is on any exponential function unless I move it. I also know that the point 1, base is on it as long as nothing's happening to my exponent. So if you shove in a 1, that just turns into a 1. Well, what is 1/2 to the first power? Any number to the first power is itself. So I have this basic shape. So I know that the point 0, 1 is on there, and the point 1/2 is on there. So I know it's going to give this general shape. Okay, and again, as soon as you know the basics, it'll be very, very, very clear which one your answer is. All right, so now we want to figure out what is happening to these graphs if we add or subtract to it. So I've got f of x equals 3 raised to the x power. So what do I know first? I know that if I shove in a 0, he's going to pop out a 1, because 3 to the 0 power is 1. I know if I shove in a 1, it's going to pop out a 3. So this graph is increasing, and it looks like that. Okay, so now I need to know, what does f of x equals 3 raised to the x plus 3 look like? So what is being changed? You've got addition on x. Well, x is your horizontal axis. Okay, so you're going to move horizontally. Remember, this is the one thing that's going to throw you off. So if I have x plus 3, that's actually going to move it to the left 3 units. Okay, so if it's plus 3, I'm going to go left 3 units. Okay, so instead of being here, I'm going to go 1, 2, 3 and plop it there. Instead of being here, I'm going to go left 3. So 1, 2, 3, and I'm going to plop it here. So he looks like this. Okay, well, what happens if I have f of x equals 3 to the x minus 2? Again, your minus 2 is attached to the x, which is horizontal. That's your horizontal axis. So you're going to move horizontally, but instead of going left 2, go opposite. So you're going to go right 2. So let's see if this works. All right, so I'm going to go right 2 units. So from your original function, instead of being here, you're going to go right 2. So 1, 2. Instead of being here, you're going to go right 2. So 1, 2. So he looks like that, and then he would come up like that. So that is the shape of your graph, okay? You're looking for horizontal movement. And then what's going to happen if you add or subtract numbers to your exponent, you're going to have a horizontal shift. Okay, it's going to move horizontally. It'll move left and right. Okay, so that's what you're looking for. Let's do a couple more things. All right, so let's try something slightly different. I have f of x equals 4 raised to the x power. So what do I know first of all? My base is improper because it's 4 over 1. So he'll increase. I know the point 0, 1 is on every exponential function. I also know that if this is just a plain old x, that the point 1, 0 is, 1 base is also on there. Because if I shove in a 1, what is 4 to the first? It's 4. So if I shove in a 1, he'll spit out a 4. So I know that this is what that looks like. Okay, so my next questions are, what if I have f of x equals 4x plus 3? Okay, well, the question is, the way I set it, you wouldn't know if it's plus 3 up next to the x or if I'm grabbing this function and going up and down 3. That plus 3 is not attached to the x. So if it's not attached to the x, this one was attached to the x, this one was attached to the x. If it's not attached to the x, you're going to go up and down. You're going to do exactly what it says. So because your plus 3 is not attached directly to the x, you're literally just going to go up 3 units. So this one will go up 3. 1, 2, 3. This one will go up 3. So 1, 2, 3. And then you just plop that thing down, and there you go again. Okay? What happens if I have f of x equals 4 to the x power minus 1. So again, that minus 1 is not attached to the x. So it's not a horizontal shift. Okay, if it's not attached to the x, it's going to move up and down, and it's going to do exactly what it says. So I'm going to drop it 1 unit. So I'm going to go down 1 from my original function. Well, my original function is the blue one. So I'm going to drop it down 1, and I'm going to drop it down 1, and then I'm going to draw that pretty picture. So what do these numbers do? It's a vertical shift. So it moves it up and down vertically, however many it says. Okay, so this one you went opposite. So the plus 3 you actually went left, and the minus 2 you actually went right. On these you do what it says. So if it's just hanging off on the end, you go up 3. If it's hanging off on the end, you go down 1. Okay, so it's a vertical shift. So let's try one more. All right, so I have a picture of an exponential function. And my picture looks like this, okay? It's kind of like that. So the first thing I want to know is my base improper or is my base proper? Okay, is my base, so we're just going to say I've got a to the x. Is my base improper, in other words, it's bigger than 1, or is my base proper? Okay, which means it's between 0 and 1. It is a proper everyday graph. Okay, so since it's decreasing, you know that it is a proper function. Well, what's your domain? The domain of any exponential function is all real numbers. The domain of any exponential function is all real numbers. In other words, how far left can I graph this thing? It will graph forever to the left. How far right can I graph this thing? It will go forever to the right. Okay, so your domain is all the x's you can use. So how far left and right will it go? It'll go everywhere. So you're going to have all real numbers. Okay, what's your range? So the range is going to be how tall it goes. So always start from short to tall. Always go from bottom to top. So what's the very, very, very lowest this thing is going to be? It's never going to drop below the x-axis. Because how are you going to make this base go negative? You can't. You cannot make the base turn negative. So you're not going to have any negative answers. Okay? So your range is going to go from 0, or all x's, all y's, greater than or equal to 0. But it can't be equal to 0. So there's no way for it to zero out. So your range is just everything positive. So look at your picture. What's the very, very, very lowest y coordinate you're going to hit? Well, it's going to be 0, but I can't make it equal 0. And then you're going to have y coordinates all the way up for the rest of its life. Okay, in other words, it will go forever up. Okay, it just doesn't do it on this picture because I don't have enough ink or paper. All right, so now I would like to know what happens if I have a to the x plus 2. So I have some random function, and then I add 2 to it. So is that vertical or is that horizontal? That's going to be a horizontal shift. I'm sorry, vertical shift, because it's not attached to the x. So you're going to go up 2 units. Okay? What if I have the graph of a to the x plus 4? Okay, well, what is your plus 4 attached to? It's attached to the x. So that tells you horizontal, and that's the one time you go opposite. So you will go left 4 units. Okay, and then we'll come back on a next video and finish practicing.